Hello, and welcome to your very first online mathematics classroom. Today we're going to start with Chapter 1, Section 2, Estimation, Graphs, and Mathematical Models. Estimation is the process of arriving at an approximate answer to a question. For example, companies estimate the amount of their products consumers are likely to use, and economists estimate financial trends. If you're about to cross a street, you may estimate the speed of oncoming cars so that you know whether or not to wait before crossing. You will find estimation to be equally valuable in your work for this class. Making mistakes with a calculator or a computer is easy. Estimation can tell us whether the answer displayed for a computation makes sense or not. In this section, we demonstrate several estimation methods. In the second part of the section, we apply these techniques to information given by graphs. Performing computations using rounded numbers is one way to check whether an answer displayed by a calculator or a computer is reasonable. Rounding whole numbers depends on knowing the place values of the digits. So if we are going to talk about rounding numbers, first of all, let's get us a number up. Like, for example, let's say 5,127,824. And if I want to round this number to the nearest thousand, first of all, I have to know where that digit is. Ones, tens, hundred, thousands. I look to the digit to be rounded. Look to the immediate right of it. If that number is 5 or larger, I'm going to increase the size of the digit that I'm rounding by 1, so I'll change this to 8 and replace all the digits to the right with zeros. So rounded to the nearest thousand, that number will become 5,128,000. If I wanted to round that number to the nearest million, I need to find the millions place, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. Look immediately to the right of the place I'm rounding to. Since this number is less than 5, do not change the value of the place you're rounding to, so I'll leave that a 5. And then all the digits to the right become zeros. So 5 million. Okay. Okay, change. Sorry guys, my computer looks like it's bogged down. Here we go. Okay, some more estimation by rounding. Although most people are familiar with pi, the number e is more significant in mathematics, and we will see it later in this course. It shows up in problems involving population growth and compound interest. An approximation for e is given right here, and it says use this approximation to round e to the nearest thousandth. Notice the th on the end of the word thousand, indicating we're talking about now the decimal position, thousandths. So again, I find that position, tenths, hundredths, thousands. I look immediately to the right of the place I'm rounding to. Since this number is less than 5, the 8 remains the same. Now on decimal roundings, I do not have to change the rest of these digits to 0. I can just drop them. So that number becomes 2.718 rounded to the nearest thousandth. Then it asks me to round to the nearest millionth. Again, pay attention to that th indicating the decimal millionths. So I've got to find that place. Tenths, hundreds, thousands, 10,000s, 100,000s, millions. Okay, the one, whoops, I need my pen, sorry. The 1 is in the millionths place. The number immediately to the right of the digit I'm rounding to is larger than 5, So I'll increase the 1 to a 2 and drop the rest of the digits. So I wind up with 2.718282. Double checking that I'm in the tenths, hundredths, thousands, 10,000s, 100,000s, millionths place. I could also be asked to round decimal numbers to a certain number of places. For example, this one asks us to round to 2 decimal places, indicating instead of saying the hundredths place, it's telling me to leave 2 decimals. So here's my second decimal place. That's the digit I'm rounding to. Looking immediately to the right of it, I see this number again is larger than 5. So I increase the digit I'm rounding by 1, making it 2.72, and since it's decimal positions, I can drop the remaining digits. Okay, let's see how else we can use estimation to help us solve some problems. What about this first one? We lease a car at $415 a month for 4 years. Estimate the total cost of the lease. Now, if I wasn't estimating, I'd actually find the exact cost of the lease by multiplying 415 by 48, right? Because it's $415 every month, but there are 48 months in a year. So I pay $415 48 times. But I just need an estimate, and so I'm going to round this $400. I'm going to round the $415 to $400, and maybe I'll round that 48 to 50. Okay, that way, this is a multiplication that I can do very easily. I don't have to pull out a calculator. I don't have to do a long process. I know that 4 times 5 is 20. And then I have 3 zeros. So $20,000 is a very nice estimate for the cost of a lease for 4 years. Okay, let's look at the next one. Traveling at an average rate of between 60 and 70 miles per hour for 3 to 4 hours, estimate the distance traveled. Well, one way I can estimate this is I can say, well, if I travel between 60 and 70 miles per hour, that means I averaged about 65 miles per hour. And if I drove that fast for 3 to 4 hours, that means I averaged about 3.5 miles per hour. So there's one way I can get an estimate. However, this requires pulling out our calculator, several steps. So something else I might think about is that, hey, the slowest I ever went was 60 miles per hour, right? And the shortest time was 3 hours. That calculation I can do very easily. I know that that tells me that the shortest distance I could have traveled is 180 miles. By that same thought process, the farthest distance I could have traveled would have been going 70 miles per hour for 4 hours, or in other words, 280 miles. Now I can see there's 100 miles between these, so right in the middle of those, a good estimate would be either add 50 to this or subtract 50 from that. To me, it's easier to subtract 50 from 280, and I get a nice estimate that I must have traveled about 230 miles. Let's go over and actually perform this computation and see what we get. 5 times 5 is 25, right? 5 times 6 is 30, plus the 2 we carried. 3 times 5 is 15. 3 times 6 is 18, plus the 1 we carried. Add them up. 5, 7, 12, carry the 1, 2. I've got 1 decimal place in the problem, so I need 1 decimal in the answer. 227.5 miles, either one, a very good approximation to the distance that we traveled. Okay, so an estimate for a precise answer or an estimate for a problem that we really couldn't get a precise answer for without knowing more information. Okay, let's look at some charts and graphs. This one in particular is called either a pie chart or a circle graph, and it's representing the most important problems for high school teenagers. Notice it's color-coded, where the big sector of blue says 29% of high school teenagers say they have other problems more important than the ones listed. 23% of teenagers think drugs is the most important problem. 22% social pressures, etc., etc., etc. I noticed that the percentage for getting into college and getting along with parents somehow got left off of our slide, but that's okay. We're not being asked a question about those two. Okay, this circle graph shows the most important problems for the, I want to keep this in mind, 16,503,611 high school teenagers in the United States. Without using a calculator, estimate the number of high school teenagers for whom doing well in school is the most important problem. All right, well, when I come up here and look at doing well in school, I see that that's 11% of our teenagers. So if I wanted to know the exact number of high school teenagers who thought doing well in school was their most important problem, it would be 11% of the 16,503,611 high school teenagers. However, I just need an estimate for that. And I notice that multiplying by 0.10 is very nice, and maybe I'll round this to 17 million just to make an estimate. So 10% of 17 million, very easy calculation to do. Multiplying by 0.1 says move your decimal one place to the left, so I get 1,700,000 as an estimate for the number of teenagers who think doing well in school is a most important problem. The next one asks us, again without using a calculator, estimate the number of high school seniors for whom drugs is the most important problem. So I go up here and I see that drugs is 23%. Well, one thing I could do is I could round that to 20%, and since I've already found 10% to be 1.7 million, well, 20% must be double this. So 20%, right, of 17 million is 3,400,000. That's an option. But I could also think about this 23% and realize, hey, that's about 25%. And I know 25% is 1/4. So if I were to round this number to 16 million instead of 17 million, then it would be very easy to do that operation and get 4 million. So you might be asking, well, which way should I do this? Well, what's the correct way? And this is an estimation. As long as we use our good estimation techniques, the particular method you use doesn't matter. Let's see what the actual answer is. Let's see if we took 23%, let's pull out our calculator, of the 16,503,611 students. Notice I get, for an actual answer, 3,795,830 students. Okay, 4 million, a good approximation for 3.8 million. Okay, and 3.4 million, also not a bad approximation. So be sure that you pay attention to the way the problem is asking you to estimate, and also keep in mind to show your work so that your estimation techniques, when necessary, can be evaluated as valid or not. Okay, well, you may go now, try some of these methods on your homework problems. Please let me know if you have any questions. Feel free to contact me with any concerns, and I'll see you in the next lecture.